Today we will approximate the definite integral of the natural log of 4x from 2 to 3 using the midpoint rule, with 5 subintervals. Then we'll compare with the true area and estimate how many rectangles we need to get an error less than 10 to the negative 6. Step 1. We divide the interval from 2 to 3 into 5 equal parts. The width of each subinterval is delta x equals 3 minus 2 over 5, which is 0.2. Now, let's visualize the function y equals natural log of 4x and the 5 midpoint rectangles. Here are the axes and the curve. Step 2. Here are the subintervals and their midpoints. We will use the midpoints C1 through C5. Step 3. The midpoint rule uses rectangles whose heights are the function values at the midpoints. Let's draw the 5 rectangles. The midpoint approximation is delta x times the sum of the function values at the midpoints. Let's write the formula. Now we plug in the specific midpoints and compute the approximation. This becomes 0.2 times the sum of the 5 logarithms. The value is approximately 2.2961. Let's compare with the exact area. The antiderivative is x times log of 4x minus x. Evaluating from 2 to 3 gives about 2.2958. The error is about 3/10,000ths. Now suppose we do not know the exact area. We can still estimate how large and must be using the midpoint rule error bound. The bound is k times b minus a cubed over 24n squared. We need k, the maximum of the absolute value of the second derivative. 4f of x equals natural log of 4x. The second derivative is negative 1 over x squared. The maximum of 1 over x squared on 2 to 3 occurs at x equals 2. So k equals 1/4. Now set the error bound less than 10 to the negative 6. We solve for n and get north greater than the square root of 10,416.66. That is about 102.06. So we round up to 103 rectangles. So with 5 rectangles, we already get a good approximation. And with 103 rectangles, the midpoint rule is guaranteed to have error less than 10 to the negative 6. Great job!